Hello, dear pharmacy students, and a very warm welcome to all of you. Today, we are diving into a subject that is, and I mean this, the absolute backbone of pharmacy, organic chemistry. Have you ever stopped to think about how a simple tablet, a tiny pill, knows exactly where to go and what to do inside our massive complex bodies? Well, the secret lies in its structure, in the language of atoms and bonds, and today we're going to learn that language together. So let's get started.
All right. Here's our game plan for today. We'll kick things off with the absolute basics, the building blocks, which are the chemical bonds. Then we'll get into a really cool concept called resonance. After that, we'll see how reactions actually happen at a molecular level, get a little sneak peek into some advanced topics, and then we'll wrap it all up with some GPAT practice questions to really solidify what we've learned.
So first things first, let's talk about the fundamentals, the building blocks. I'm talking about chemical bonds. These are the invisible forces, the glue, that holds atoms together to form all the amazing, complex drug molecules you'll be studying. Honestly, understanding these is step one to understanding everything else in pharmacy.
Now, the most common type of bond you're going to see in organic chemistry is the covalent bond. The whole idea here is sharing electrons. It's pretty straightforward. You've got a single bond where two atoms share one pair of electrons. Then you have the double bond, where they share two pairs. And you guessed it, the triple bond, where they share a whole 3 pairs of electrons. Simple as that.
Okay, now look at this table. This shows a relationship that is super important. This is a very important concept for GPAT, so listen closely. Notice the trend here. The single bond is the longest, but it has the lowest energy. That means it's the easiest to break. But as you move to a double and then a triple bond, look what happens. The bond gets shorter and shorter, but the energy needed to break it gets higher and higher. The takeaway? Shorter bonds are stronger bonds. Remember that.
Right, so beyond those basic covalent bonds, there are 2 other interactions that are absolutely critical in pharmacy. First up, we have polar covalent bonds. This is what happens when the electrons aren't shared equally. One atom pulls them a little closer. This creates a tiny charge. And why does that matter? Because it's everything when it comes to a drug's solubility, its ability to actually dissolve in our body, which is mostly water. Then we have hydrogen bonds. Now, these are more like strong attractions than true bonds, but they are incredibly powerful. They're the reason proteins fold into the right shapes, and they are key for that perfect lock-in key fit between a drug and its target.
Dear pharmacy students, if you're finding this lecture helpful, please subscribe to the PharmaEd channel. Hit the like button and share this video with your batchmates. Your support helps us create more quality content for pharmacy education.
Okay, now let's build on that. Sometimes, you just can't draw a molecule in one single way that tells the whole story. This happens when the electrons aren't stuck between just 2 atoms. They're actually spread out over several atoms. And for that, we need to understand a concept called resonance.
So what is this resonance thing, really? Well, it's basically a way we can represent a molecule by drawing a few different possible structures. But here's the most important part. None of those drawings are the real thing. The actual molecule is something in between, a beautiful blend of all of them. We call this a resonance hybrid.
Now, there are a few simple rules to follow when you're drawing these structures. And the number 1 golden rule is only electrons move. The atoms themselves stay put. You also want to make sure you're following the octet rule and keeping charges as low as possible. So what's the big deal? Why do we care? Well, resonance makes a molecule way, way more stable. When you can spread those electrons out, the molecule just becomes more settled, more stable. This is especially true for things like benzene rings, which you see in so many important drugs.
Great! So now that we have a better handle on what molecules look like, let's get into the action. Let's see how they actually interact with each other. This is all about the dynamics, the step-by-step process of how chemical reactions go down.
In almost every organic reaction, you've got 2 main characters. On one side, you have the nucleophile. The name says it all, nucleus-loving. These guys are rich in electrons, and they are looking for a positive center to donate their electrons to. And on the other side, you have the electrophile, the electron-loving species. They're electron-poor, they're looking for electrons. And basically the whole reaction is just a story of the electron-rich nucleophile attacking the electron-poor electrophile. That's it!
Now, this table right here, this is a very, very important topic for GPAT, so please pay close attention. It compares 2 fundamental types of reactions, SN1, SN2. Look at the rate. The speed of an SN1 reaction only depends on 1 molecule. But for an SN2, it depends on 2. And look at the stereochemistry, the 3D arrangement. SN1 reactions give you a mix of products, but SN2 reactions cause a complete inversion. It's like a glove turning inside out. Understanding these key differences is absolutely essential for your exams.
Fantastic. Now that we've covered that, let's take a quick look ahead at a couple of more advanced topics. You'll study these in much more detail later on, but it's always good to get an early introduction, right?
So first, stereochemistry. This is all about the 3D arrangement of atoms in space. And in pharmacy, wow, it is so critical. You can have two molecules that are perfect mirror images of each other, we call them enantiomers, but one might be a life-saving drug while its mirror image could be inactive or even toxic. The tragic story of the drug thalidomide is a powerful reminder of why this matters so much. Then there's aromaticity. This is a special kind of superstability that certain ring-shaped molecules like benzene have, and it's all determined by a set of rules called Huckel's rule.
Whew! Okay, that was a lot of theory. Now it's time to put that knowledge to the test. Let's work through a few practice questions, just like the ones you might see on your GPAT exam. Are you ready?
All right, question number 1. Which of the following is true about nucleophiles? Just take a second to look at the options. A, B, C, or D. What do you think? The correct answer is A. Remember what we said, nucleophiles are nucleus-loving, and that means they are packed with electrons and are always looking to donate them. Question 2. Resonance in organic chemistry does not do which of these things? Read the options carefully now. Okay, got it? The answer is B. This is that golden rule we talked about. In resonance, only the electrons are allowed to move around. The atoms themselves are locked in place. It's a classic trick question, so always be on the lookout for it.
And for our last question, which type of bond has the highest bond energy? The correct answer here is C, the triple bond. Just think back to that table we saw. Remember the relationship? The shorter the bond, the stronger it is, and the more energy you need to break it. And the triple bond is the shortest and strongest of them all.
Fantastic job with those questions. Now let's just quickly recap the most important points from today's session.
So here are the key takeaways you absolutely must remember. First, bond types. Single, double, and triple define how strong a molecule is. Second, resonance is your key to understanding why some molecules are so incredibly stable. Third, all reactions boil down to that dance between an electron-rich nucleophile and an electron-poor electrophile. And finally, those differences between SN1 and SN2. You have to know them inside and out for your exams. Now, if you want to go even deeper, I really recommend checking out these books. They are the gold standard when it comes to organic chemistry, and I've put the details for you in the description box below.
And that's a wrap for today. Thank you so much for joining me. I really hope you found this session helpful. Don't forget to subscribe to PharmaEd for more lectures just like this one, designed to help you excel in your pharmacy studies. Keep learning, keep working hard, and all the very best.